We discussed about need of classification as well as the classification started by Mendeleev, right? So he tried to arrange that elements as groups made by three elements. That three elements were selected into the group based on the atomic weight, right? Then that three elements also with the property first and third element, right, made a group of three elements. In that he followed increasing order of atomic weights. Then first to last third element average is equal to the second element atomic weight. So this he observed. Then this is only given as Dobereiner's law of triads. So okay, he tried, but finally it is not possible to arrange all the available elements in the form of triads, right? So that's why they are given as here limitations for the law of triads, right? So what is that? It could not be possible to arrange that elements in the form of triads. Okay, something he tried and he arranged the elements in the group of triads. So 5 triads he made, right? You need to remember that names of the triads also, right? So first one, it is I'm taken as LINAC. So lithium, sodium, potassium. I'm pronouncing as LINAC for my convenience. I'm using that as LINAC. So here lithium, sodium, potassium. One of the example for the triad. One of the example for the Dobereiner's law of triad. So second example here I am naming as Castroba, but writing as like this, right? Writing as like this, Castroba, calcium, strontium, barium. Naming as Castroba, right? So first example LINAC, second example Castroba, third example I'm giving as chlorobro-I, chlorine, bromine, iodine, chlorobro-I. It is for my convenience only. Just you need to use the symbols using the starting letter of that pronunciation. Chlorobro-I, chlorine, bromine, iodine, right? The next one I am giving it is like a suicide, but I am giving you as suicide, right? So sulfur, selenium, tellurium. Then the last one is mancro-I, manganese, chromium, and iodine. So these are the 5 examples of Dobereiner triads. So here they may give you in the multiple choice question 3, they will give you correct in the same as the Dobereiner made, but the 4th one they will change, right? So you need to identify. For that purpose, compulsory you need to keep them in your mind. So with that pronunciations, I am able to remember them simply. LINAC, Castroba, chlorobro-I, Suset, and mancro-I, right? So if it is comfort, you can remember. Otherwise, you can make your own what a simple logic. You can create your own logic, right? So this is my logic to remember these triads. Okay, here these are the triads available. In this, everywhere you are able to see the atomic weight of first and last average is equal to the second. No. So in case of second group, third group, that means B, C, D, E. In them, you are unable to find the atomic weight exactly as mean or average of first and last. Only the first one you are able to find. Exactly as 23. But remaining, they are not giving you. So that is the failure. It is not possible to arrange all them in the form of triads. And the another is this law is failed for very low and high mass elements. And average also not exactly. Then what the atomic weights assumed by Dauberiner, right? They are not standing exactly for the experimental values. So is there any confusion in the Dauberiner law of triads? Just bring into my notice if there is any confusion. Otherwise, go for quick reaction. So nothing. Very good. So we'll go for next classification. Why we are going for next classification? Can anybody give me clarification? Why we need to discuss about next classification? Because Dauberiner failed to arrange the elements in a particular manner or a process to explain, right, why this classification, right? So that is the reason for changing that classification of elements. So now we are discussing about another classification made by Newland, right? So John Newland was a British chemist, right? He tried to arrange the elements, right, using atomic weights, right? So he was the scientist, Newland. He tried to arrange the elements in a manner, but unfortunately, this manner that what he tried to arrange the elements, right, that classification was not accepted by any other. At least it is not published in the science journals, right? But he suggested one of the best method, right? One important point is there to observe through his classification, right? So let us discuss about Newland's law of octaves. As per Dauberiner law of triads, the Dauberiner tried to arrange the elements in the increasing order of atomic weights, right? And he made or he tried to make a group of elements, right? Increasing order of atomic weights followed, and he tried to make a group of 3 elements. So just he also thought like a Dauberiner. He tried to classify the elements same in the increasing order of atomic weights and also tried to make a group of elements, but not with 3 elements. He tried differently. He made a group of elements with 8, right? So elements are arranged in the increasing order of atomic weights, right? As Dauberiner tried, right? So Dauberiner made group of triads. Here, group of 8 elements, 8 according to that count. In chemistry, we will follow that count of 1, 2, 3, 4 like that, a mono, di, tri, like that. So 8 means octa. That group of elements made by 8 elements named as octave. Octave means group of 8 elements. So he tried to arrange that elements in the increasing order of atomic weights. He observed one pattern. Why he is arranging the elements in the increasing order of atomic weights? He arranged that elements as 8 elements, a group of 8 elements. So here that every 8th element is observed as the first element chemical properties. That means it is resembling the properties like the first element. Every 8th element resembling the properties like the 8th element. That means here he observed that repetition, properties repetition. So when elements are arranged in the ascending order of the atomic masses, they fall into a pattern in which their properties repeat at regular intervals, right? So that's why he tried to make a group with 8 elements. So that 8 elements groups are named as here octaves. So every 8th element resemble the properties of starting element in a group of 8 elements. They are only called as here. They are only called as here octaves. Right. So this law is called Newland's law of octaves. This law is called as Newland's law of octaves. So here it is given by Newland. That's why it is named as Newland's law of octaves. So what is the periodic law of Newland? Simply we can write the same. When the elements are arranged in the increasing order of atomic weights, they fall into a pattern, right? So resembling the properties, right? So every 8th element resembling the properties same as the first element. So this is observed and this is only given as periodic law, right? So this we can write about Newland's law of octaves. So here simply if you observe the periodic table which is published by Newland's in 1866, that is given in the page number 126 of your textbook. Just look at that periodic table if you have textbook. So here he arranged what the elements are available at that time. All the elements not available. Just he used it to arrange the elements what they discovered at that time. So he do not left, right? He do not left any space for the newly discovered elements, right? No space is given for the unknown elements, do not found, not predicted any element with certain properties, right? So many failures are there in this periodic table. So before going that, here one more important point you need to learn, that is about the comparison of these elements properties. So what he said, every 8th element resemble the properties of starting element in groups, right? Group of 8 elements. So first element to 8th element resembling the same properties. First element to 8th element resembling the same properties. Due to that reason, what he thought to say, so simply octaves behavior compared with musical notes in a Indian system and also in a Western system compared with the musical notes. So in our Indian system, what the musical notes are there? 7 musical notes are there. They are here sa, re, ga, ma, pa, da, ni. What about the next note? Repeats. First one, right? So every 8th note again starts with sa. So again repeats sa, re, ga, ma, pa, da, ni. So like this, so every 8th element property also compared with the musical notes, right? So depending on the lyrics, you may change that musical notes combination. How it will be accepted for the elements, right? So maybe repeats, but depending on that, you may change the combination of that musical notes. How we can accept that comparison of properties in the same manner of musical notes? So this is also one of the failure, right? So Western musical notes, do, re, mi, fa, so, la, ti. So these are the musical notes in Indian system and in a Western system. So every 8th musical note repeats the first one and so on. So cyclic process, right? So that is compared in regular intervals, but it is failure. So here simply what these are given in different systems, naturally every 8th note is similar to the first one, but how we are able to compare? Vikrant, I think you only. Just unmute. What happened? Mute yourself. Harshit. No, not Harshit. Someone. Okay. Thank you. So here, naturally, it is happening in the musical system, but that comparison or how he compare the both same. So it is failure, right? But the best thing is he tried to assign a number for the elements, right? He tried to assign a number for the elements. So at the time, just nearly 56 to 60 elements are available. That classification is given, and that elements are given with the number. He tried to assign a number for that. So that is only here taken maybe as atomic number later on. So a new point, a new thought is given in his classification. Why don't we assign a number for the elements? So that classification is given. The best thing is assigning a number for the atoms, right? So he was the first person to assign a number for the elements. So what are the limitations, right? So the limitations are here. Simply, if you observe, you will find in the same slot 2 elements. For example, in the page number 126, you will find in the first horizontal row, 2 elements are given in the same numbered slot, that is cobalt and nickel. Like that, you have many elements which are fitted into the same slot: platinum, iridium, barium, vanadium, silurium and lanthanum, dysprosium and molybdenum, right? So similarly, you can find other also. So why they are fitted into the same slot? No explanation. 2 elements are fitted into same slot, but what the reason for them? Then totally dissimilar elements are fitted into the same groups. For example, here, what are the octaves here? Horizontal rows or vertical columns? Horizontal rows are here given as groups, right? So here simply 8th element fall into the same. So here 8 elements were taken as groups, right? So how they are resemble the same properties? Completely dissimilar elements are given into that. For example, here are hydrogen, fluorine, chlorine, or gases. Bromine also a gas. But what about this cobalt, nickel, palladium, iodine, like platinum, iridium? They are metals, right? So how they resemble the same properties, right? Suppose if you compare this hydrogen, lithium, they are also not same. They are different in their properties, right? So these are the failures. Dissimilar elements are fitted into the same group. The next one here, that periodic table only restricted for the 56 elements. It is restricted only for 56 elements. That means there are no new discovering elements in the future, right? So these are the limitations. So no slot is given for the newly discovering elements. Did not leave room for new elements. And Newland attempted to link these arrangement or classification of elements with the musical notes. The periodicity of musical notes is similar to the elements? No. Right? So we cannot compare that. So these are the limitations. These are the limitations, right? But the best thing is assigning a number for the elements, right? So is it clear about Newland's atomic weight? Sorry, atomic classification. So these are the points you need to write about the classification of Newland law of octaves, right? So this is about Newland's periodic table, right? So the next attempt to ask, because there are limitations. So this classification is not enough to classify the elements. So that's why you are learning about another periodic classification is Mendeleev, right? Mendeleev's periodic table. So it is given by Mendeleev, right? That classification was given by Mendeleev, right? So this classification almost a success, but there are minor inversions. Due to them, again, it is also remained as failure story. But given successful information to classify the elements. Because here, if you observe the classification which is given by Mendeleev, remains same for the successful classification. Same as the successful. So Mendeleev arranged the elements not at that time, right, in a chart in the increasing order of atomic weights. So in his classification also, he depended on atomic weights only, not the other. He also depended on the atomic weights, not thought differently. So periodic classification simply depended on the atomic weight. But the new thing is he depended on the chemical properties also. Not only by the atomic weight, he also thought about chemical properties. So based on the chemical reaction, he thought to classify the elements into a manner, particular order for the classification. So Mendeleev arranged the elements known at that time in a chart in a systematic order, that is in the increasing order of atomic weights. Not only by the atomic weights, also he selected the elements particularly into a vertical column, right? So increasing order of atomic weight, that means you can write in a straight direction. So 1, 2, 3, 4, like that, so on. But here, not only in the straight, he selected that elements into the different rows, right? Based on what? Simply based on similarity, right? So that which comes into this vertical column, that must be with the similar chemical property, right? So what that property is? Chemical property. Simply that he tried to give, it is as valency. So based on the valency, he selected that elements into the vertical columns. Vertical columns. So he divided the chart into 8 vertical columns known as groups. What about the horizontal rows? That horizontal rows are taken as periods, right? So it is for regular intervals. That is called a period, fixed time. After that, it resembles same from the starting to ending. Then here, that what the vertical columns are given by the Mendeleev periodic classification, they are called as groups. Again, that groups are divided into further called subgroups, was named as A and B. So here subgroups are given as A and B. Then here elements are in a group, they are having the similar properties, because here the elements are selected into these vertical columns based on the valency. Means what? Here he used that chemical properties, reaction of the elements with oxygen. Then what the chemical composition given by that elements? Similarly, for example, here a group of elements reacting with the oxygen and giving you the chemical composition as RO. For example, here magnesium oxide, calcium oxide, right? Like this, right? Some other, suppose I am taking sodium, Na2O, it is giving, right? Like this, or Li2O, like this. So similar chemical composition for them that suggested as R2O. Maybe they are giving you as R2O3. I mean, R2O3, like this. So many he thought. Suppose here Fe2O3. So valency predicted in the chemical composition reactions, right? So that is the wonderful thing to select the elements into the vertical columns, right? So that selection also into the different groups as A and B. So that groups are here given by the different numbers. He used Roman numerals for the groups. They are given as 1A and 1B, right? Then the elements which fall into the horizontal rows are called as here periods. They are in the increasing order of atomic weights, right? Into the vertical columns, they are with the similar properties. Valency is similar, right? So similar in the chemical properties, especially in the vertical columns, no similarity in the periods. So horizontal rows are called periods, vertical columns are called as here groups. So in the vertical columns, you will notice that chemical properties are similar. In horizontal rows, no similarity. Then here elements along periods has different properties. Then next here, Mendeleev's periodic law. What is given here, periodic law? So simply he tried to give a relation between physical and chemical properties. Based on what? Based on simply same atomic weights. So that's why here his periodic law given by him is followed here. Simply he tried to explain the similarities of elements in the groups in terms of the common valency. So chemical properties also used, and he arranged the elements based on the atomic weights. Then the physical properties also explained. So that is the reason to give the periodic law is followed here. What is physical and chemical properties of the elements are periodic functions of their atomic weights. So based on the atomic weight, that periodic functions means that regularly they are changing, right? So that depending on the atomic weights. So Mendeleev's periodic law was written as here physical and chemical properties of the elements are periodic functions of their atomic weights. So this is the periodic law of Mendeleev's. So like this, he tried to classify the elements, right? So based on this, now we are going to discuss about main features, silent features. What he explained clearly in his classification or in his periodic chart, right? So 3 periodic laws we discussed up to now. What about that? Dauber-Inner law of triads. Next, law of octaves, Newlands. The next, Mendeleev periodic law. So in the Dauber-Inner law of triads, he given that periodic functions of their atomic weights, right? So periodic functions of their elements depending on the atomic weights only, but they made a group of 3 elements called as triads. Then in the next attempt, that periodic functions only based on the atomic weights, but made a group of 8 elements. But there is no fixed count is given for the groups and periods, right? No fixed count is given, right? He classified that elements especially into the number of groups and periods, but not with the number of elements, right? So this is we are observing in the periodic classification given by Mendeleev. Is it clear about periodic law of Mendeleev's? Is it clear? Right. So now we'll go for silent features of Mendeleev periodic table. Join immediately in the next meeting. We'll start our discussion. This meeting time completed. Join in the next meeting.